Welcome back, Math 20-2. Today we're looking at equivalent forms of rational expressions. This is very much related to stuff you've done a long time ago. It's nothing that new. You've done a little bit of this in grade 10, and you've done this also in grade 8 and 9, the very basics of this, but you've done the actual rational expressions before. So when we look at fractions, that is a rational expression. And if we want any equivalent fractions, or break down a fraction to simplest form, that is very similar to what we are going to do with rational fractions. Here's an example of 18 and 42. So we want to figure out a number that divides both of these. I always do the factor tree. I go 18, well that's 9 and 2, and then here we have 3 and 3. So I have my factors, and I write out all the factors on top, 3, 3, 2. All over. Now I have 42. What is the factors of 42? Well, I have 6 and 7. Well, this is 2 and 3. So that's 2, 3, 7. Okay? Now I look at this, what cancels off? I have a 3 and a 3. Or 3 and a 2, and 2 and a 3. 2 divided by 2 is 1, 3 divided by 3 is 1. So we are left with 3 over 7. Okay? So we're dividing the numerator and denominator by something. So what's another equivalent fraction if we multiply them both by something? So we could also multiply both of them by 2. So 18 over 42. Well, that's the same thing as we could multiply both by 2. So that's going to give me 84 and 36. Okay? Multiply both the top and bottom by 2. What we do to the top, we must do to the bottom. Factoring and dividing both, well, this one here, we could have just divided them both. Factoring and dividing, I kind of did this. So write a different answer for each part in part A. We'll just skip that. So that's the main ideas, equivalent forms. These are all the same as that, just like 1/2 is the same as 2/4, or 3/6, or 4/8, or 7/14. Those are all 1/2. Okay? So here we're going to have a little investigation for you, but we're going to kind of skip that. It's with rational expressions and the x's. Okay? But we are going to skip that here and go straight on to this. Now, write the equivalent form of this rational expression. Okay, so here we go. It says write the equivalent form of that rational expression by dividing both the numerator and denominator. Well, look at this. Both of these could be divided by 2, factoring out the factors. So both of these could be divided by 2. So that's the same as both divided by 2, 8x divided by 2. And then we have 6x divided by 2. And we have minus 4 divided by 2, which gives me 4x all over 3x minus 2. Multiplying a number and denominator in, so we want to multiply now. So I can multiply everything here by what? Oh no, 2. So that's 16x all over. And 2 multiplied by both of these is going to give us 12x minus 8. So if I multiply everything on the bottom by 2, I have to multiply both. Remember, distributive law. Now factoring and dividing. So factoring and dividing. Well, the top is the same as 2 multiplied by 2 multiplied by 2 multiplied by x. Because 8 breaks down to 2 and 4, 2 and 2. So that's 3 2's. Okay? All over, 6 is the same as 2 and 3. Those are the prime factors. So we have 2 multiplied by 3 multiplied by x. Okay? And we want to subtract. We have 4. It's 2 and 2. 2 multiplied by 2. So everything in here and everything there, what's the same? We have a 2 is in the same of everything. So it's the same thing as 4x all over 3x minus 2. I really like this way here. It really makes it so we can get as simplified as possible. So now it says, which of the following equivalent forms of the rational expression? So this first one here. I look at this is 12. Well, I multiplied the 6 by 2. Here, I multiplied the 2 by 2. But did I multiply the 1 by 2? No. This is actually not the same. If we were to graph these in our graphing calculator, we would have different curves, different graphs. So they are not the same. Okay, let's take a look at the next one, negative 18. Well, that means I multiplied this by negative 3. That means we must have multiplied everything here by negative 3. So that should be negative 6x. Good. Negative 1 multiplied by negative 3 is positive 3. Ah, this is true. This next one looks like we're multiplied everything by x squared. Okay, so the top is x squared. The bottom, we have to multiply by x squared, so 2x cubed. And this one, minus 1, and that's x squared. That's only x. So there's my problem. That one doesn't work. Let's try the next one. We have the 3. Okay, and then x minus 1. Well, this is divided by 2. This is divided by 2, and this is divided by 2. So, no, that one doesn't work as well, because this should be 1/2. So that's a no as well. So there's only one of them is the equivalent. Now let's take a look at example 4. Consider the rational expressions for the following. Okay, so here's my rational expressions. Draw and evaluate the expression for x is equal to 0. Okay? And based his answers on, he concluded the rational expressions are equivalent. Comment on his conclusions. Well, if he said it's 0, and this, these are two graphs. We have to give more than one, because on two graphs, if they might intersect, and where they intersect are equivalent. So normally we have to use more than one point. Okay? So we have to do more than one point. If he just said when x is 0, I could even go something like this. 2x plus 4, is that the same as 2 or 5x plus 3? Are these, or plus 4, sorry, plus 4. Are these the same? I could put a 0 in for this one. That is 0 plus 4 is equal to 0 plus 4. And by looking at that, I could say, hey, look, these two graphs are the same. But we know they're not. This graph will look like this. Whereas this graph will look more like this. Just at 0, they intersect. That's it. So he has to actually convert them and cancel them down like we did there to show they're the same. One way of doing it is finding the common factors. Well, let's take a look at this. We could, if we divide it, this seems to be divided by 2. So that is 8 divided by 2, and 4 divided by 2, minus x divided by 2, which gives me 4 all over 2 minus x over 2, which is not the same as that. Okay? So these are actually not the same. Just because one value is the same doesn't mean they're the same. They just intersect there. So you have to make sure by trying to convert this equation to that one. You can't just put in a variable and say, hey, look, they're the same. Okay? So that is everything for this one. One more thing is the non-permissible values. You have to always state the non-permissible values first. So if we did have an x squared and we're canceling on an x squared, you have to state that non-permissible value first if we're factoring out an x. So I'll see you tomorrow as we work on these together.